Hi everyone, my name is Gaby and I'm a solution engineer at Esri. In the next few minutes, we're going to see how we can utilize GeoAI to detect objects in imagery and validate those objects through multiple data sources, all within a single dynamic interface. To get started, let's define what AI is. Artificial intelligence is the idea of achieving human-level intelligence. A part of that is utilizing machine learning, which is a field within AI that's about learning from data to derive rules and extract patterns. Deep learning is one type of machine learning that is becoming very good at extracting patterns from highly unstructured data, like images and text. You can find AI capabilities in many ArcGIS products today. For example, ArcGIS API for Python includes the ArcGIS Learn module, which is good for deep learning. We also have machine learning tools in ArcGIS Pro, our desktop software, as well as other capabilities ingrained into ArcGIS Enterprise, ArcGIS Notebooks, and more. When it comes to extracting insights from imagery, there's so much we can do within the realm of GeoAI. Object classification and detection, pixel classification, image translation, these are just a few of the different tasks we can complete. Within a machine learning lifecycle, our goal is to train a model that we can then apply for inferencing and extract insights from those results. Using ArcGIS, we can streamline imagery analysts' workflows by using models and deep learning tools to do the bulk of the work for us. One of the tools we can use is the Detect Objects Using Deep Learning tool. We can use this tool in the web from our portal, as we see here, or at the desktop level in ArcGIS Pro. This tool runs a trained deep learning model on an input raster to produce a feature class containing any objects it finds based on the model's specifications. The model can be trained using the ArcGIS Deep Learning Studio or by a third-party model software such as TensorFlow or PyTorch. The model can also be pulled from Esri's Living Atlas to make inferencing much easier without having to train a model of your own. For this example, we are going to use a plane detection model we've trained with our imagery. Running the tool, we now have our detections and a confidence score letting us know the confidence in each detection. In this particular case, we took several days of imagery and wanted to compare the change in detections we saw in one day with that we saw in another. Instead of running the deep learning tool for each day of the imagery manually and doing the spatial analysis for every airport boundary, we can streamline this process and make it even more efficient by using an ArcGIS notebook to do the work for us. The notebook will execute a deep learning tool and do the spatial analysis for us, then update any necessary data with those calculations. To review those changes, we added our findings into an ArcGIS dashboard that shows us the total detections that day, any planes outside the airport boundaries, a map of our detections, and a list of airports from the state and if there were any changes noted. Utilizing the Detect Objects tool with our pre-trained model, we were able to quickly and efficiently detect objects and use an ArcGIS notebook to automate our inferencing and analysis, further streamlining our workflow. Using these deep learning tools, we can detect objects much quicker than we could without them. And all of this analysis is housed within our portal and can be shared out to our entire organization. Thanks for joining me with this quick look at how AI can help save analysts time and how the use of the entire ArcGIS system can streamline workflows and be shared out throughout their entire organization. If you have any questions, feel free to reach out. Thanks.